Welcome back. Let's talk more about sets. Specifically, let's talk about something called a Cartesian product. Now, what is a Cartesian product? Well, it's an ordered pair, meaning I'm going to have two numbers or two things, because we don't have to be numbers. They could be lots of different things. A and B, where A and B happen to be in a specific order. Now, this is the difference between a set and an order. The order is exceptionally important because it tells us something. Again, and further, if I have two tuples or ordered pairs that are the same, the elements in the same spots have to be the same. So in other words, A and C have to be the same and B and D have to be the same. If that's not true, if one of those fails, then we don't get to say that they're equal. So we utilize this in a lot of different situations to kind of work our way through. So let's just look at a couple examples to get this in our brains. You can pause, try to answer these questions. Give yourself like 30 seconds, should be pretty quick and easy. Go ahead and try. All right. So if we look on the first one, and I'll go ahead and actually show you the answers for the first two, we actually see that 1, 2, and 2, 1 are not the same because we changed the order. So while the elements are the same, then we have an issue. Next, for this one, they are the same because 3 is equal to the square root of 9 and 5 is equal to 1/2. 5/10 is equal to 1/2. So because I could simplify them, the values were the same. They just were in a different form. That is perfectly fine, perfectly legit. This is not like words where you have to have them exactly capitalized for all of you programmers out there. Now, if we look at the last one, 1 and 2 are called the elements. So again, I'm going to take you all the way back here. The elements of an ordered pair are the things that are in it, and they have a first element, except now we just say that they actually have a specific order. So it's like a set, except that order matters and repetition matters now. So that's okay. Now we get something called an ordered n tuple. Okay, that's just a fancy way of saying instead of ordered pair, I'm just going to do it for n times. X1 through Xn. Now that's one way to do it. Some of these also are written, not all. Your textbook didn't do this, but I have seen plenty of textbooks where they actually start at X0 and then they do X1, X2, and so forth up to Xn. If they do that, it's okay. You start it usually at 1 or at 2. And again, they're equivalent if and only if we do this. Now, it only does this for a finite number of elements, and truth is, you don't have to be finite, but it just makes it a lot easier and nicer, and that's all we're going to deal with in the class. All right, so let me ask a question. Let's look at these examples. Are these equivalent? All right, I know I'm jumping in real quick, but hopefully you can pause the video if you need more time. The answer is, for number 1, or A, is no. And for B, it is yes. For B, 3 is the square root of 9 still, 3/6, and then -2 squared is equal to +4. However, the order of the last two elements in the first one has changed. And again, order matters in these ordered items. That's why we name them that way, to try to give you a red flag and give you a heads up. What do I care about this? Because we get into something called Cartesian products is how we create these. I start with a set of sets, usually n sets. And then I write a, notice these look like multiplication symbols that you did as a kid. So we don't use multiplication as an operation on sets. If I do that, it literally means that the first element comes from a big A1. The little next element comes from the next set. The next element would come from the next set, and so forth and so on until we get to our last set and last element. So always, this is just a way of creating ordered pairs. So let's look at an example and actually practice creating these. So let's just look at the first 4 for a second. We'll come back to the others. If I want to know what is A cross B, that means I am going to literally start, I'm going to make, it's going to give me a bigger set in the element. So I'm going to pick something from A. So I'm just going to start with X. And then the second element has to come from B. So 1. And then I could do, again, I could do X. And I could do 2. And then I could do X and 3. And then I could do Y and 1, and so forth and so on until well, there's only 2 more that end up. If I was to do this, this literally is going to look the same way, except all it is going to switch the orders of every single one of these ordered pairs. Now, if I do A cross A, my first, I'm going to have X, and now I'm going to come back and I'm going to pick something from this one, so I might as well pick the first one, X, and then I'm going to have X, Y, and then I'm going to have Y, X, and then I'm going to have Y, Y. So now you'll notice something. The first one, these first 2 have a total of 6 elements. This one has 4 elements. The reason being because I have, in the first spot, I have 2 options for this. And each one of those has 3 options to go with it. So 2 times 3 equals 6, which is where we get the 6 elements. However, when we did A cross A, it was 2 elements for the first one and 2 elements for the second one. So there were 4 possible combinations. So this idea of how many elements is a critical part. We'll come back and talk about this more. And we can just take it up a little bit further. All right, let me clear that out of the way. All right. Now, as for when I do A cross B cross C, the interesting part is the parentheses kind of end up being very, very important. I first have to create A cross B, which is going to give me the ordered pair inside of another ordered pair. So it's important how you write this. So if I had written this as, let me come over here, as A cross B cross C with no parentheses, then when I've ordered pairs that essentially would have had X, 1, and A, notice there's no parentheses inside the actual ones. However, as soon as I throw parentheses in here, parentheses go around the corresponding elements, and it gives me this ordered pair as an element within it. I know it's a little bit slight difference, but again, how we put parentheses is very, very important. All right, let me just skip ahead to this one. I gave you an R cross R. Well, that's going to give you all the ordered pairs X, Y, where X and Y are both real numbers. You know this as when we talk about Cartesian products, because the Cartesian plane is the XY plane that you all are highly familiar with and have done so much of your algebra and other things in, because it is real numbers, that's the X, by real numbers, because every point, it can be any real number in each things. All right, let me move on to another important thing that we're going to talk about that especially you computer scientists might recognize. It's something called strings. Now, these are used a lot in both computer science and mathematics. A string is a Cartesian product because order is really, really important. Replication is important. The one little difference is there is no parentheses or commas. And the elements are called characters of the string. A null string is, well, it's blank. And sometimes you use lambda to represent the null string. If A is 0, 1, the string is called a bit string because it has, in other words, the elements are built out of bit strings. So getting an example, a bit string could look like 0, 1, 1, 1, 0, 1, 1. This is a bit string that if we counted it, we would notice that it has 7 different characters. And each character has a specific position. this character is in this position, this character is in this position. And there's nothing more to really read from that because it is a string. It means something. That's why all of you computer scientists, when you enter in a string in a computer for a name, like if I was to write math, it's different than the string math because this character is different than that character. That is why strings are different. Now, we use a lot of different strings and we kind of play with them and utilize them. Now, so if I did something like this, though, I said A is the elements AB, and when all the bit strings of length 3 with at least 2 characters that are the same. So that means I have to have 2 A's or 2 B's. So I can have, but it says at least. So I could have all 3 that be the same. So for instance, I could have A, or I could have A, and B, or I could have B, A, or here's another one, A, B, A. That's just going with the A as my 2 characters that are being repeated. And it gives me all these different ones. Notice there were no B's at all, a B in the last spot, a B in the first spot, and a B in the middle spot. So that's our options. Similarly, the B's, you'd have 4 of them because you'd have B, 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 followed by, well, you can guess it, B, B, A. I could go B, A, B, and then A, B, B. So all these 8 are what make up this total set of strings that we are looking at possibly in this situation. All right, I hope that helps you. Let me know what questions you have and have a good one.